Morning.
Yeah, so as Zach said, I'm Mike Denninger, and I'm Vice President of Theme Park Development at SeaWorld Parks and Entertainment. So I work just in Orlando, but we have 12 parks in the United States. You know SeaWorld probably in Orlando, Florida there, and we have a SeaWorld in Texas, and we also have one here in San Diego. So I'm right here standing in front of Manta, which is it's different. If you guys, I don't know if you guys have just by a show of hands, who's been on Manta in SeaWorld Orlando? All right, okay, so Manta.
We had a seventh grade class field trip to SeaWorld. So several students in here have just gone last week to SeaWorld.
Oh, fantastic! That's fantastic. Great, good. Well, so Manta in Orlando is a flying coaster. So when you sit in, the seats are pitched forward, and you're put into a flying or a prone position. And this coaster here, this Manta is different in that you're seated upright, but we have this really cool launch experience that starts inside of a show building, and you see all these manta rays swimming around you in the show building. We move the train forward and backward to kind of simulate being in the current of the ocean, and then you launch out. You go all the way up to about 42 miles per hour, and you launch out, really high acceleration, really thrilling, and it's got this great ride experience that weaves throughout the park here. You can kind of see the track maybe here behind me a little bit more, and it goes way off into the distance. Maybe you see the track back behind me over there. I'm a mechanical engineer. I went to University of South Florida in Tampa, USF. So I went there for my bachelor's degree in mechanical engineering, and I also have a master's degree in mechanical engineering, and I also have a master's of business administration. And so that education, that additional education, it's proven pretty useful for me personally, because SeaWorld, we're not an engineering company, and when you think of engineering, and maybe you think of STEM and the subjects of STEM, I think a lot of people always consider that those subjects are only for scientists or people who just focus on doing calculations all day, and those sort of subjects, which those are there and those are important. But maybe one of the messages I want to get across is that it's more than just science and research, but there also is very applicable real-world issues that have to be solved, including those in a theme park environment. So my role has me looking over all attraction development for all 12 of our parks. So I have a handful of engineers and project managers, and so what we do is we're responsible for designing, creating, and then building all of the attractions that go into all the SeaWorld and the Busch Gardens park. So if you rode Mako last week at SeaWorld Orlando, did you guys ride Mako?
Yeah.
Who rode Mako? All right, so Mako is one of the projects that we just finished last year. Great ride, great roller coaster. Lot of engineering, ton of engineering, a lot of science, a lot of planning, a lot of technical work goes into all of these projects. So I guess the in terms of I'd like to understand what you all are studying in relation to science and engineering, and what I'd like to do is have a conversation here, so I don't have to do all the talking, but I'd like to hear if there are any questions related whether to theme park design and engineering, or even science, technology, engineering, math, any of the subjects of STEM that you all have as it relates to the real world.
Does anybody have any questions? Bradley?
Is it hard, like when you're doing like all the calculations to like do the rides and stuff?
He asked,
Thank you.
Yeah, he asked, is it hard to do the calculations as you design the ride?
Well,
and the math.
I think, and the math. Well, I kind of like the math. You know, and I think when you get into technical fields, you'll find that there are some of the fields that just appeal more to you, maybe than they do to others. When it comes to attraction design and development, and namely like roller coaster design, like when you see this coaster behind me here, there is a significant amount of design process and calculation. There are some very sophisticated computer programs that are used now for modeling, where we can lay out the ride sequence and simulate the ride motion. And the reason that's important for like a roller coaster, maybe differently than a building, is that, you know, a roller coaster is a dynamic structure. So the loading and the unloading of the track changes as the ride rolls around the track. They were just running the coaster here, so you may see it. It is kind of early here. The park's not open yet, but we go through our morning checks every day. So you might see the coaster run behind me while we're talking here. But as that really heavy mass, which is multiple tons, rolls around the track, it loads different portions of the track different ways. And so there's an onset of load, and then it maximizes, and then it tapers off until the next train comes along. And the design process that is gone through is very much from a structural analysis. So that is done first. So we start off with doing static calculations. Static means not in motion, so it's not changing over time. So we just consider the weight of the track, the wind, the load that's on the track, any dead load that would be on the track. And then we go into a more sophisticated analysis, which is dynamic analysis. That is a lot more difficult because you're looking at that onset of loads. And so to answer your question of if it's hard, I wouldn't say it's hard. It's very sophisticated and it's complex. But it is what we do, and we also work with a lot of really bright engineers and other designers and planners that do this for a living. And so when you do something again and again, you become really good at it, and you develop some really strong skills. So it's just like when you all are doing some subject in school, whether it be math or science, and it may be new to you when you first start it, but once you work on it and you work through the process of how to do a certain subject or topic, then you're much better prepared to do it the next time. And then if you do it again a third time or a fourth time, it becomes more second nature, and you actually develop stronger skills as it relates to completing your work assignment. And it's very similar to ride design engineering, whereas most of the rides we put in our parks are not copies. Like, well, this one is called Manta behind me. It is nothing like Manta in Orlando. Manta in Orlando, you hang on the underside of the track, and there are a significant difference in how the train is loaded and how the train loads the track. But there are very similar analysis and processes that are used to look at the dynamic loading of the structures.
Great. A follow-up question was, what is the salary range for someone working in theme park design, ride design, engineers working on these coasters?
Yeah, okay, so salary range for engineering in general, and I'll speak towards engineering because that's what I'm most familiar with. But salary range for engineering, when you have a degree in engineering, or maybe even more advanced, multiple degrees in engineering, it usually starts relatively high compared to maybe other professions, and it has to do with the challenge of going through the educational process. And when you have to work harder to get through some of the educational process, usually there's a bigger payoff at the end. So starting salaries in this field, are anywhere in the range of probably as little as $40,000 per year up to from a starting standpoint, probably $70,000 a year on a starting standpoint. And you know, what is different about theme park work, and I touched on this earlier, that you know there are STEM careers virtually everywhere, because technology is everywhere. It's all around us in everything that is done. And so while theme park design requires engineering, it's not an engineering field. So specializing in this field is a little more difficult. As you can imagine, there's not just tons and tons of roller coaster engineering jobs. There's only a handful in the world. And so while it is a specialized field, so those individuals who are in those specialized fields can, if they're really good at what they do, they can usually demand a higher salary. And so when I say a higher salary, you know, I'm talking, you know, 120 to $180,000 a year in some of these fields. And what I have seen and what I have experienced is that when you're technical based, like me, so I'm a mechanical engineer, and I'm a professional engineer also. When you're technical based, but you can also bridge your technical abilities with the business that you're working for. So like I went and I got my Master's of Business Administration because I knew that I liked being technical, but I operate and I work in a field that's really a commercial business. I mean, we are a theme park company. We're not an engineering company. We require technical people in our company, but really we're running a business and we need to make sure we are successful in our business. And so by bridging the technical with even business in this case, you can fall into these really great roles where these roles require someone to have strong technical skills, but they also need someone who can speak to our business and finance people, and not just work solely on mathematic problems and technical issues. We have to do that, but we also have to talk when it comes to the overall business. And so typically these roles are probably more prevalent because there are more business-related roles in a non-engineering, non-research company than that would require a technical skill than there would be just a singular technical position. So it is interesting that you can, you know, your STEM background can set you up to move into positions that otherwise other people cannot get because maybe they didn't follow a STEM course or a STEM line of courses in their education. So it's a great place to be, and it's also maybe it's not always apparent to students. I know it wasn't to me when I was in school. I mean, I didn't go to school to be a roller coaster engineer. That is not what I started out doing. But because of my engineering background and so my multiple degrees in engineering and business, and because I started getting theme park experience, I was sort of predispositioned to keep moving along in this field, and it's a great field to work. As you can imagine, I mean, we design attractions. We come up with the ideas. We work with lots of creative people, lots of artistic creative people, and then we also put together really technical plans to design something that our guests, when they experience it, it will be a very memorable experience that they enjoy, and that will want to make them come back again, maybe with their friends when they leave our parks.
Excellent. Any other questions about? Yes, Marianne. Oh, so she asked, on average, how long does it take from start of the design to the finish of the project to create a roller coaster or a ride, an attraction like Manta or something like that?
Yeah. All right. So it takes roughly 3 years from idea, like the concept of the idea, through the completion of the project, you know, about half of that is spent in design, where we sort of really formulate and brainstorm what the attraction is going to be, because we have to create the idea. You know, there's nothing that says, okay, well, the next thing that's going to be done at SeaWorld Orlando is the tallest, fastest, longest roller coaster in Orlando. That didn't exist. I mean, it starts with a strategy that we put together, and you know, we consider the attraction mix that's in our parks and the attraction mix in the market. So, you know, you think of Orlando, it's the busiest theme park market in the world, with all of the Disney and Universal parks. And so when you consider that, what you have there versus maybe what you have in some of the other markets that we operate in, it's really highly competitive, and differentiating your product is very important. So we do spend a fair share of time crafting the idea and coming together on it. The actual hard engineering work, where we've selected the concept and we are working hard on designing it so that we can come up with buildable construction and fabrication documents. That design process probably takes a year, and then the construction of it takes the remaining 18 months or so to put up, you know, from when we put up those construction walls that are in the park up through our completion of when we open for the first time to our guests.
And you mentioned the design process. That's something that we kind of work in here a lot. This is a STEM class. Do you guys write up a design brief for kind of like the people that are overseeing the project as engineers? Would you write up a brief kind of explaining you know, what your plan is and what your roller coaster is going to look like and all of that?
Yeah, we do. We actually speak, because we're a theme park company, which is maybe it's a little special, right, in terms of what we do. We start with what we call a creative narrative. Now, I say creative, but remember, this is an attraction, and there's a lot of aspects to the overall attraction of what it has to deliver. So the creative narrative goes into all the details with regard to the final concept that we've selected. You know, and remember, we're developing multiple concepts. There is not always just a singular concept that is the one we're going to build. We may work through a concept design on, you know, 4 different concepts. And some, like this Manta coaster behind me, there were concepts when this coaster opened in 2012. This one did not. It wasn't just a coaster. We had some other really great attraction concepts that we worked through. And so as you work through them, you kind of, you know, the really, really great ideas tend to bubble up to the top. And there are sometimes multiple ideas, and it's hard choices of which one to go with. So sometimes we even keep those ideas, and we might roll them out again and test them maybe in a different market or so. But that creative narrative sets up the overall strategic direction for the project, and it also details the technical aspects. And for us, because we're theme parks, there's always a story. There is always a story that becomes the guiding creative principle of the project, and we sometimes have to work those stories into the technical aspects of the project. So for this coaster, Manta, you start off the ride in this media tube, like this tunnel with media completely around you, and there's great audio and visuals around, you know, and it's just surrounding you, very immersive. And that is the story of the attraction, because otherwise it's just a roller coaster. And there's nothing wrong with it just being a roller coaster, but what we try to do is create a little more meaning in the experience, because if we can touch people a little differently, and, you know, and we give them not just maybe a dynamic coaster experience, but we also maybe tie into some additional emotions and some additional different feelings that they otherwise, or things that they just don't typically think of when they ride a ride. Like, oh wow, I feel like I'm a cheetah and I am launching just like a cheetah would run, and I'm going 60 miles an hour, which is the speed of a cheetah. You know, it's the fastest land-based mammal. So if we can make people feel like they are the cheetah at Busch Gardens Tampa on Cheetah Hunt, then maybe they'll have a different connection to that animal, and might even choose to look into what can they do? Is there something in the world that they could do that is related to that animal? So it's really for us about creating these really unique connections with nature. That's, you know, we are SeaWorld. That is what we do. Part of our mission is to protect the natural wonders of the world, and we do it even with something that is very dynamic, like a roller coaster.
Any other questions about roller coasters?
So, yeah, if there are no other questions, I can talk for a few minutes about a couple of different technical aspects of some of the rides that we work on. I'm happy to do that.
Yeah, Adrian, did you have a question or no? Oh. Sorry, I gotta come up to the microphone because it's on the webcam. What are
No, that's no problem.
One student was asking what kind of safety precautions do you have to keep in mind, because you have like hundreds of people riding these things a day, and they seem like they could be that dangerous, right? That's like what makes them exciting. So how do you guys keep them safe for everybody to use?
Yeah, that's great. That's a great question. You know, safety is paramount in everything we do. Because if something's not safe, then it's not good for anyone. It's not good. It's not good for guests. It's not good for us. You know, we are in the business here for people to come and have these memorable experiences, and for them to be concerned about something not being safe would not tie into that overall great experience. So safety is it's where we start on all of our projects, and it is consistently throughout our projects, and it's embedded in our culture of what we do in our parks and everything we do, not just the rides and the design, but maybe even the fencing that we have around our rides and how our stations operate. And remember, it's not just safety of our guests, but we also want to ensure the safety of all of our team members and also our animals, because we have a lot of animals in our park. So safety is abound in everything we do in all of our designs. On ride design, I get very involved in the overall safety of our attractions. A lot of times we're doing things that have not been done before, and you have to understand things like, well, you know, what if the ride shuts down? You know, because the ride is a machine, and machines inherently do break down. So when any ride system breaks down, we have to ensure that it enters a fail-safe state. So a fail-safe state means that under any condition, whether it be loss of power, maybe there's an electrical problem, maybe there's a mechanical failure, under any of those conditions, there are a certain set of redundancies that exist so that it never causes a hazard that is not something we can control. So that process of looking at the severity of the hazard and the likelihood of the hazard, so we look at severity and frequency, that is called a hazard analysis. And we go through a very, very complex and very detailed hazard analysis on every attraction that is done in our parks. So, for example, we can talk about, I think what people think the safety systems are, they always think of the restraints on the coaster, which those are. Those are a vital part of the overall safety system. And restraint design is based on years and years of experience with looking at how the body responds to forces and the size of the patron that's in the seat and the restraint. And that's why some rides have certain minimum rider heights to ride, and even some manufacturers require certain age of individuals to ride, because age is a determinant of the maturity level typically of the rider. And sometimes you just can't take a very young rider and put them in a situation that is very, maybe for them, scary, and they may react with a behavior that is not ideal, even for the restraint system that you have. So typically typically that maturity is governed by height, because you can assume that certain people of certain height are a certain age. There's also a very complex and a very thorough control system that looks over the ride to ensure that the ride is operating in the manner in which it was designed. So while we design them, and then we build them, and then we test them, and we do a significant amount of testing before something is ever operated to the public, and we test them, like you guys may have seen pictures of coasters with these big plastic, they look like bodies in the seats, and we typically refer to those as water dummies, because we fill them with water, which creates a ballast weight, and so it simulates the load of the patron. So we go through those testing. We also go through a lot of other testing that you probably don't see, which is related to ensuring that the systems that were designed and were put in place are functioning the way that they should. So it's sort of an evaluation and an acceptance process, or it's also called site acceptance testing, SAT, you may hear referred to. And so those tests and the process of going through that testing is a critical part of any new attraction. And then, even after the attraction's open, I mean, these rides are inspected every single day. So all of the critical safety functions and all of the functions that are deemed to be inspected every day by the ride manufacturer or by our park, we conduct hours and hours of inspections every single morning, usually before you guys wake up, because we're out here inspecting these rides usually in the 3 a.m. hour or so, 3, 4, 5, and 6. We're usually doing what we call our green tag inspection. And the green tag basically says that the ride is ready, it's operating within the parameters it is supposed to operate within, and it's ready for our use by the public. So it's very complex, and there's lots of different avenues of how safety is implemented. And you know, we do a lot on our side. We do everything that we can on our side, but we still do need our guests to have a certain sense of responsibility, because we can put up the tallest fence in the world. Like you see this fence behind me, you know, and this fence is it's almost 6 feet tall, and this is what, you know, this is what separates you from the hazard of the ride. If you decided to jump the fence, I mean, how much tall? I mean, there isn't a fence tall enough that someone couldn't jump. So there still is a responsibility on the patron that they will look out for themselves also. We just want to make sure that we look out for all of the other things that are maybe not typical and are not typical hazards that our guests would encounter in the world, in their normal life.
Great. I had another student ask while you were answering that, how much does it cost to build one of these rides? Like a ballpark estimate.
Yeah, all of the attractions that we do, these are multi-million-dollar attractions. Usually the larger attractions that you see in our park, they are multi-tens of millions of dollars. Occasionally, attractions can get up to 100 million, or even over. It depends on the complexity and the size of the attraction. That could be easily over $100 million in one attraction. So that's not just a coaster now, remember, because it's more. This is more than just a roller coaster. There's all of the things you don't see, the underground foundation system and the utilities. There's a lot of architecture that we build because we are a theme park. We have to have themed architecture and facilities. So we have maybe shops, and we have restaurants, and we have restrooms. And so there's things, and then the thing that we do that's different than most parks is we usually always have some sort of an animal tie-in. So Mako, for example, we had the existing shark encounter, but we connected the attraction with the shark encounter so that it feels like all one experience. And so we still put money into the overall build and the architecture of that ride. Or you think of Manta, which is the flying coaster in Orlando. We built an enormous aquarium right in the middle of the queue line. So when you're in line for the ride, you're actually looking into an aquarium. And so those are industrial systems. You know, those are systems that have to operate every single day. We have to ensure the safety and the livelihood of the animals that live in those systems. And so that does take a lot of ongoing expense, not just upfront. There is considerable upfront expense, but the ongoing expense is significant also. It requires a lot of skilled people, whether people who are in the biological fields, water quality, animal husbandry, and all those fields that are also other avenues of STEM-related work and careers.
Awesome. Did anybody have any other questions? Adrian? What is, yeah, the student asked, what does general maintenance look like on a roller coaster?
Okay,
Like
so
maintain them.
yeah, okay, so maintenance on a roller coaster is broken up into two, sometimes three. It just depends, but it's at least based on two types of maintenance. And the first type of maintenance is preventive maintenance. And so preventive maintenance includes all of the daily inspections, and it includes all of the preventive replacements, and we look at like the common wear and tear items. With the roller coaster, there may be certain components that the manufacturer stipulates requires a replacement after so many cycles or after so many months of operation. And so all of that work, that is preventive maintenance, and that work is done ongoing. And so there are things that are required to be done daily, there are things that are required to be done weekly, and there are other intervals. There are things that are required to be done every 2 months or every 6 months, for example. So all that is preventive maintenance, and so we do that constantly, as you can imagine. We have a team of mechanics at every park, and they're split up, both electrical and mechanical skill sets, and those people are responsible for ensuring the ongoing daily technical operation of the ride. The other part of maintenance is the annual maintenance. So the manufacturers of all of these attractions require some type of annual, it's usually a complete dismantling of the ride system. So not the track per se, but usually it's for a roller coaster it would be the train. So every train on these rides is completely dismantled, and we do very detailed inspections that are called NDT inspections. That's NDT stands for non-destructive testing. So that requires things like ultrasonic testing, and we do magnetic particle testing. We're looking for the signs. The word we use is indications. So we're looking for indications of potential failures on any of those members. So like if there's a stress crack that maybe is just starting, you might see it in the weld. And so if you find those things, you're usually depending on the situation, you're usually removing the entire weld and then going back and putting a brand new weld in, or maybe it's that you're looking at your bearings on your wheels and you have to repack the bearings on an annual basis because after a while the frictions and the grease inside the bearing starts to wear. So it's significant. If that wasn't apparent, there's a significant amount of maintenance that is required of these rides. So just like a car requires work, and if you don't take care of your vehicle, then what's going to happen? It's going to break down, right? And so we don't want our rides to break down, because when our guests come to our park, there's an expectation that when they pay an admission to come into our park, that they will be able to experience everything that our park has to offer. So while we can't always do that, because and especially in SeaWorld Orlando, at Busch Gardens Tampa, we never close. We're open every single day. Christmas, New Year's Day, any holiday, we are open, and we're open for business, and people are coming. And so what we have to do in those parks versus maybe a seasonal park that is not open all year is we plan the maintenance of those ride systems so that maybe we don't have multiple rides closed at the same time. You only have so many months in a year to work with, so you've got to figure that out, because you want to try to not impact when you're busiest in your season, and because when you have more people in the park, you want to make sure that you're making as many people as you can happy with their overall park experience. So it takes a lot of planning and organization, but you know, this is something that we do, and it's something that our maintenance groups do every day. So it's not difficult. Again, it's more about proper planning, understanding the work, working through it, and then also, you know, occasionally things do come up that might be unusual. In older ride system, you may see things that you hadn't seen before. So having long-term experience on these ride systems is beneficial to properly troubleshooting, working through the issues, and eventually getting the ride back in its proper working condition so we can open it up for our guests.
Great, thank you. We just have a couple more minutes left here in the class. Is there any other last-minute question that anybody wanted to ask? Eric? How much one student asked, how much have they spent this year? What do you mean, like in one theme park or in all 12 of it? I doubt he's going to know how much they've spent. He wants to know how much roughly SeaWorld has spent on their rides this year, or on.
Well, okay, so we spend money a couple ways. All right, so we spend money on new attractions, and that is typically called capital spending, because we are creating assets that go into our parks. Okay, so there's capital spending, and then we also have the ongoing spending that is required to keep our business going, and this is called expense. So expense spending and capital spending, the reason that it has two different names is because the finance people, the accountants, can treat that spending differently and how it hits our finances and hits our books, because capital is based on investing the money into maybe an attraction or something that we intend to have a return on investment. And expense spending is intended to just get our parks going every day and keeping our parks operating. You know, our parks are like a small city. You know, we have major. So you guys hear that? So that's the Manta ride that's going to start behind me here. So we might get to see a couple coasters go over before we're done here.
Unfortunately, our bell's about to ring in just probably 30 seconds or so.
Is it really? Okay.
Yeah, so I think we're going to have to call it as well over here.
Okay. All right. Well, it was a pleasure talking to you guys, and I wish you the best in your continued studies.
Thank you so much. Everyone,
thank you, John, and thank you, Mike, so much for the presentation today. Bye, guys.
All right, thanks a lot, Mike. We really appreciate it.
All right. Yep, no problem. Anytime.
Yeah.
Take care.
Talk to you later.
All right, great. Have a good one, guys.
You too. Bye-bye.
All right. All right, thanks, Zach.
Yep, thank you, Mike. Talk to you later.
All right. All right, bye-bye.